Chained inequalities are when we have two inequalities in the same expression. They often are good for providing an upper and a lower limit. So in this example, what I'm saying is that x must be greater than 4, but less than or equal to 10. Happy with that? So the unknown value must go in the middle of our chained inequalities. Clear with that?
Yes.
It does not make sense to have, for example, 4 is less than 10. That does not make any sense at all, does it? So inequality, with our inequalities, our unknown must go in the middle. And this links to solving values on the same side, because we're going to get to the point where we're solving chain inequalities, where we've got values unknowns in both components, or in multiple components. So I've got two unknowns here, correct? And if we don't have a process following that, we get ourselves in trouble. With these, I can do it all in one hit, but I can do some of it in one hit, but I can't do all of it in one hit. But let's get back to this because we need to understand this before we can progress on to this. 6x plus 9 is greater than negative 3x plus 30. What's the problem with this? Jake, what's the problem with this question? Or this expression? What's the first thing I need to fix up?
No idea.
No idea? What's the goal? I was trying to get x by itself, correct?
Yeah.
What's the problem? Variables on both sides of the expression, correct? I need to get rid of them from one side. I always try and go to the biggest side so I get a positive value of x. So which value is bigger, 6x or minus 3x? 6x, so to get rid of minus 3x, my first step is I add 3x to both sides. And I'm left with 9x plus 9 is greater than 30. I have a habit of picking bad numbers for this, but anyway, I've kept up with that trend. How do I get, what do I do now? Yeah, reverse bombard, subtract 9. 9x is greater than 21. Divide both sides by 9. X is greater than 21 over 9. I'm just going to leave it in that thing there. Cool? I thought I was going to get 3 over 3. But I stuffed up. When we get to these ones here, okay, if I've got an example like so if I've got 55 is less than or equal to 5x plus 5, which is less than or equal to, or greater than or equal to, I don't know, 75. What I can do in that scenario is I can subtract 5 from this one, subtract 5 from this one, subtract 5 from that one. Are we clear with that?
Yeah.
And I can attack that just like every other problem I've dealt with. So I have 50, 5x, 70. And what would I do now? Divide everything by 5, correct? And I'll be all good. The difference between that and this is that I've got expressions on both sides. So if I'm given an expression, an equation where I've got unknowns in multiple parts of my inequality, what I need to do is break it up into segments. So I might look at this segment first. So I shouldn't be left with that when I break them up individually. And then once I've got my final answers here and here, what do I do with those values?
Put them together.
Combine them into one inequality where I've got 10 is x is greater than or equal to 10 but less, greater than 10 but less than or equal to 16. Are you clear with that?